In this lesson, we are going to apply the law of cosines to be able to solve either angles or sides or both of non-right triangles. Now, when we take a look at the law of cosines, we want to determine what we should use or when we should use this as opposed to using the law of sines. There are a couple of instances that we will want to take a look at. First of all, we want to use this when we are given two sides and an inclusive angle, which means that we are given, for example, we might be given side A and side B, and then we have also been given angle C, which is called the inclusive angle. It is between the two sides that are given. Another situation where we might want to use the law of cosines is when we are given all three sides. And no angle measurements. Okay, now remember that these are used for non-right angle triangles, so non-right triangles. And you'll notice that even though there are three formulas written down, they really are all the same. So basically, a squared plus b squared minus 2 times ab times the cosine of c equals c squared. So you can recognize in these particular formulas that we have part of the Pythagorean theorem, or the Pythagorean theorem embedded in here. But because it is a non-right triangle, we do have to do a couple of other things. We have to subtract 2 times AB. In other words, no matter what sides you are given, you're going to multiply or square both of them, and then subtract 2 times each of them. And then you multiply that by the cosine of the angle that is included. So let's do an example. So here we have the two sides that are given. So we have side C is equal to 16, and we have side A, which is equal to 12, and then we have our inclusive angle B, which is 38 degrees. So we want to find side B, and we also want to find the measurements of angle A and angle C. So we can start off by using one of our formulas. Since we're looking for side B, we have B squared is equal to a squared, which a is 12, so we have 12 squared, plus c squared, which is 16 squared, minus 2 times both of those sides, 12 and 16, times the cosine of 38 degrees, which is our inclusive angle. Now all we have to do is use our calculator to finish. So we have b squared is equal to 144 plus 256 minus 384 times the cosine of 38 degrees. And when we put that into our calculator, we are going to get b squared is equal to approximately 97.4. But we don't want to know what b squared is, we want to know what b is. So we're going to take the square root of both sides, and then b then will be equal to approximately 9.87 as the measurement of side B, or we could round it to 9.9. So now what we would like to do is we would like to find the measurements of angle C and angle A. And in order to do that, we may want to make sure that we use something that's a little bit easier. So you'll probably want to use the law of sines to solve the rest. So for example, if I have the sine of 38 degrees, I can put that over the measurement that I just calculated for B, 9.87. In other words, the sine of B divided by, or compared to, the side measurement of B, which is 9.87. And I can set that equal to the sine of angle A as compared to its side measurement, which is 12. So what we need to do then is to multiply both sides by 12, and then we'll multiply that by the sine of 38 divided by 9.87, and that's going to equal the sine of angle A. So that comes out to be 0.7485 as our sine of angle A, and we will need to use our inverse sine to find our degree measurements for 0.7485, and that equals about 48.5 degrees. So now, since I know that angle A is approximately 48.5 degrees and angle B is 38 degrees, we can add those two together and subtract from 180 degrees, and angle C then is approximately 93.5 degrees. Let's do another example. In this example, we're given all three side measurements. We need to find the angle measurements. So we can decide what we would like to solve for. I'm just going to use, we're going to solve for the cosine of angle A. And it doesn't matter, you can decide and pick whichever one you would like to do. So in that case, I have A squared, side A squared, which is 8 squared. And that equals B squared, which is 18 squared, plus C squared, which is 13 squared, minus 2 times 18 times 13 times the cosine of angle A. So we can see then that we're actually going to solve and find the degree measurements of that angle. So we use our calculator to simplify. We have 64 is equal to 324 plus 169 minus 468 cosine of A. So simplifying, we have 64 equals 493 minus 468 cosine of A. Subtracting 493 from both sides, and that gives us a negative 429 is equal to negative 468 times the cosine of A. So I'm going to divide both sides by negative 468. And when I do that, I'll get approximately 9.917 is equal to the cosine of A. So to find the degree measurement of that particular angle, we want to use the inverse cosine of 0.917, and that's going to be approximately equal to 23.5 degrees. Now, once we know one of the angle measurements, again, it might be best to go back to the law of sines to find one of our other angles. And so let's set up the proportion in order to solve. So if I have the sine of angle A, which we calculated as 23.5 degrees, and we're going to set up a ratio which would then put that over the measurement of side A, which is 8. And then we can set that up to the sine of C over the measurement of its side, which is 13. So So we'll multiply both sides by 13. So we have 13 times the sine of 23.5 divided by 8 is equal to the sine of angle C, and that comes out to be 0.648, which then is equal to the sine of angle C. And so we'll use our inverse sine to find the degree measurement for angle C of 0.648, and that's equal to approximately 40.4 degrees. Now we have the degree measurement for angle A and for angle C. And if I add those two together and then subtract that from 180, we have angle B having a measurement of 116.1 degrees approximately with our rounding. So you can use the law of cosines when you are given two sides and an angle in between, or an angle inclusive, or we can use the law of cosines when we're given all three sides of the non-right triangle but no angle measurements. Looking at the law of cosines, remember that even though this looks complicated, basically this is exactly the same formula. And when we do calculate it, if we have the variable being squared equal to the rest, then that is what we use as finding the cosine of.